All right, in the previous video, we defined and described what an acid is, what a base is. Now let's talk about some reactions characteristic to acids and bases. Okay? Start off by reminding you that we had defined something called metathesis, an exchange reaction before, with this pattern, right? It's simply a switching of two cations or two anions, you recall. All right. So we had that, which gives us this. Okay, and we defined that initially with a precipitation reaction. So we defined this exchange, and one of the products was some insoluble compound. Okay. We're going to be discussing these next two, acid-base neutralization, now that you know what an acid-base is, and then gas-forming neutralization reaction, which is also an acid working. All right. So here it is again. Acid-base neutralization reactions. Here's the characteristic pattern. You've got an acid and a base, and this is going to generate water as one of the products and a salt. What do we mean by salt? Historically, salts were just that, one of the products created by an acid and base. You can also think of them as an ionic compound, meaning you're going to have some cation bound to some anion. All right. Here's an example. Hydrochloric acid plus sodium hydroxide. Strong acid, right? Strong base. When these two react, you get sodium chloride, there's your salt, plus water. All right. Now, the ionic equation, start out by writing, remember the complete ionic, break everything down into ions. These are your reactants. So the HCl, H plus, chloride. Sodium hydroxide, sodium hydroxide. What's on the product side? Okay. On the product side, all right. On the product side, remember what we do. You break down any ions that are soluble. So we got the sodium and the chloride still around, plus any unique product, which is water. All right. So what then is the net ionic equation? Remember, all you do is cross out things that are on both sides, the same on both sides of the arrow. So here's a sodium, cross that out. Here's a chloride, cross that out. And hence, for any strong acid, strong base reaction, this will be the net ionic equation. H plus OH minus gives us water. All right. So that was the characteristic net ionic reaction for a strong acid and strong base. What about weak acids? Remember, weak acid is something that doesn't dissociate completely. So here's my challenge. Let's write a net ionic equation for the reaction of a weak acid plus a strong base. All right. There's your acid, there's your base. This is acetic acid, if I didn't say this before, this HC2H3O2. So one of the rules about writing the ionic and net ionic equations is that for any weak electrolytes, we don't write them as dissociated into ions. We keep them together. Hence, our complete ionic is going to have this as a reactant. Right? This is a reactant. Remember, the sodium hydroxide comes from the base. All right? What's on the product side? All right? We're going to break this down into cation and anion plus water. Then what is going to be the net ionic equation? Again, simple. Just cross out anything that's the same on the left side of the arrow as the right side. So we're just going to cross out that sodium. So the net ionic equation is the undissociated acid plus OH minus gives us C2H3O2. That's the acetate anion plus water. Okay, so again, watch out for weak acids when you're writing these equations down. All right, so that was a acid-base neutralization reactions, both for strong acids, strong bases, and weak acids and strong bases. How about this category 3 called gas-forming neutralization reactions? Again, we stay with this generic pattern where we're switching cations and anions. All right? We've got an acid and a base, but instead of forming water and salt, we form a gas. So what's a good example of this? Here we go. This is a reaction of hydrochloric acid plus sodium carbonate. You say, why is that a base? We'll get to that in a second. That gives us a salt, sodium chloride, and hydrogen carbonate. What is that? Why is that a gas? Well, big question mark. Let me show you something. There's the reaction again. Turns out that this compound is not very stable. All right, so what turns out to be a base, excuse me, on this side is the carbonate ion. Okay. It accepts a proton, H+, and we get the bicarbonate ion. It will accept another proton, and now we've got H2CO3. All right, but the problem is not stable. This will break down into CO2. There's your gas. So the net overall reaction is this. Excuse me, the overall reaction. Sodium carbonate plus HCl gives us the gas, CO2 plus water and sodium chloride. All right, so this is a unique reaction that you'll need to recognize. All right. What about other potential gas-forming acid-base reactions? Okay, there's only going to be two others that you'll be responsible for. That comes about from the sulfite ion, sulfite. This is sulfite. Sulfate is SO4 2-. Okay, so the sulfite ion, when reacting with an acid, gives us SO2 gas. So there's your gas, okay, plus the salt plus water. And then the second one is the sulfide ion, S2-. So sodium sulfide, okay, reacts with an acid, and you get hydrogen sulfide. That's that sulfur-smelling gas, really stinks. So here's your two gases. So again, watch out for the carbonate ion, which will generate, when paired with an acid, it will generate CO2. Okay? The sulfite ion, which when paired with an acid will generate SO2. These are gases. And then the sulfide ion, which will generate, sorry about that, let me go back. All right, we'll get to those slides soon. Generates H2S. These are all your gases. All right, so acid-base neutralization reaction, salt plus water. Okay. Acid-base gas-forming reaction, a salt plus a gas. And we said there's three that you need to be responsible for. Here they are. So let me make sure you're clear on that. These are your bases. Carbonate ion, sulfite ion, and sulfide ion. When those react with H+, you'll get a gas. All right. So that's the end of this acid-base neutralization reaction. Our next in this series is going to be talking about oxidation reduction reactions.